Good morning friends, myself Dr. Kushal Bhattacharya. Today we should discuss about fatigue loading. Now fatigue loading is a very important aspect of mechanical engineering is as far mechanical engineering and automobile engineering is concerned. The reason behind this is very simple because 80% of the failure which takes place in automobile parts or mechanical parts is due to fatigue loading. Now fatigue loading is that type of loading which repeats itself with time and it is not constant with time. So like monotonic loading, so it repeats itself with time. Now as it repeats itself with time, so there is a very difficulty for analysis such components which are prone to fatigue loading. Now to understand how fatigue loading takes place, there are several that is stress varies. Stress can vary in several ways with time. Stress can vary in several ways with respect of time. But for the sake of simplicity and for the sake of analysis in the graduation level, I should consider the variation of normally people consider variation of stress as sinusoidal wave, as which is the most acceptable known to everybody. The stress varies sinusoidally with respect to time for the sake of simplicity and for the sake of analysis. But I told that in mechanical components, it is not. Mechanical components does not know physics, does not know mechanical engineering, so they are subjected to any sort of variation of stress with respect to time. But for the simplicity of the model, we should study over here the sinusoidal wave. Now you could see that this is a type of sinusoidal wave. These are types. This is called a fluctuating stress, this is called a reverse stress, and this is called a reversal stress. Now you see that the fluctuating stress, it is in the fluctuating stress what happens, we plot time in x-axis and we plot stress in y-axis. Now you see as the stress varies sinusoidally, the peak maximum stress is called sigma max and the minimum stress is called sigma mean, and the average stress sigma m is given by sigma max plus sigma mean. Sigma max plus sigma mean by 2, it is called the mean stress and it is shown as a mean line. And another component which is called sigma alternating stress, sigma A. Sigma A is given by sigma max minus sigma mean by 2. So this is a component of a case of a fluctuating stress. Now here you could see this is the component of a reverse stress. Now what reverse stress has? You see the reverse stress what has over here, you see the minimum component, the minimum sigma mean plus sigma mean by 2. Now over here sigma minimum is 0. Sigma minimum is 0. For this reason what happens? For this reason what happens? We get a value of sigma max by 2. Now for sigma alternating what we get? Sigma alternating we get sigma max minus sigma mean by 2, but over here sigma mean is 0, so we again get sigma alternating stress is also sigma max by 2. So it could be seen that here sigma mean and sigma A are same. Here over here sigma mean and sigma alternating are stresses are same. Over here you could see sigma mean and sigma alternating are same. Now over here we get the value of the completely reversal stress, which is a very dangerous. Why completely reversal stress is very dangerous? Because in the this is a condition of tension fatigue, because as it is positive it could be tension, load could be bigger, the pull. Suppose if you are pulling something like this, if you are pulling a mechanical component specimen like this, a testing specimen like this. So if you are pulling and this is held constant, so it is a reaction force. Now if you are pulling, it should be under tension. It should be under tension. Now once the tension is increasing and then the tension is decreasing. Tension is increasing and tension is decreasing. Over here what happens? Tension is increasing and it again comes to 0. That means tension is reduced to 0. Tension is again increasing and reduced to 0. But over here it is a completely different story, because here it is a completely reversal stress. When in case of completely reversal stress, you see you got a tension force. Over here. If you see a completely reversal stress, this condition is very much different. This condition is very much different for a. Suppose you are pulling an I section like this. Your cylindrical specimen, this is the gauge length. Now you are pulling like this. So what happened? Tension in the upper phase, and the next phase you are going for a compression. So tension in the upper phase, one phase, and next tension you are pulling it in a tension, it goes to a maximum, then you go to a minimum, and you are coming to a compression force. Compression force, you are compressing it to the minimum, and again compression is reduced again, and again tension moves up. You could see as you are pulling this specimen, the tension moves up. The tension moves up. Now what happens? The tension reaches a maximum, the tension reduces to 0. Then compression starts. It compressing, and compression becomes maximum. Then again it moves up, compression 0, then again it tension. Now this is a very difficult case, and most about 90% of the failure among the in fatigue failure, this is one of the most dangerous case of fatigue failure, because it is what happens with a completely case of a completely reversal stress. Because normally a material could be good in tension and a material could be good in compression. For example, if we take mild steel, it is a very good property. It is a very good property if we consider ductile. If we consider tensile test, it is a very good property, as it is because of ductile material for tensile testing, or for where the tensile load is applied. But if you consider cast iron, what happens? It is a very much brittle material. It is very good for compressive forces. As that is, the resin cylinder blocks are made of mainly cast iron. Now when two properties are required at the same time, that is, it should be good for tension and it should be good for compression. So here it becomes a very much difficulty to assume material properties like that, or to make more materials like that, so that it could be very good in tension and also very good in compression. So that is the most dangerous case of over here. So this is the most dangerous case, you see. That is now what happened over here? What happened? Sigma max is what? Over here, sigma max is given by sigma max over here is given by sigma max plus sigma mean by 2. Now you see sigma max plus sigma mean, both are positive, and what happens? Sigma max plus sigma mean by 2 minimum. Now over here this is plus, and what happened? This is minus, because it is acting in a different way. Minus by 2, what happened? It's 0. So in this condition, what happens? Sigma mean, that is the sigma average is 0, sigma mean is 0, that is the minimum stress over here is 0. That not some minimum, sigma mean, that is sigma average stress is 0. That is sigma average mean, or actually average, average is written by sigma minimum, mean, MEAN, mean. So over here the sigma mean is 0. So you could see this line is the line for the sigma mean. It is passing through 0 line. Now what happens? Sigma, now you go for what happens? Sigma average. Now sigma average, what you should get? Sigma average, sigma alternating. For sigma alternating, what you should get? Sigma alternating is given by sigma max plus minus sigma mean by minimum. This is minimum, sigma max by sigma minimum by 2. Now if you put this value, what happens? So in case of sigma minimum, what happened? Both are minus, so it could be both could be minus. So if this could be minus, so minus and minus becomes plus. So what happens? Sigma max and minus of minus sigma max by 2. So what it will becomes 2 sigma max by 2. So 2 cancels, so it will become equals to sigma max. So alternating CA, it becomes equals to sigma max. So over here you could see sigma max minus sigma mean, so it will becomes plus, so it will becomes 2 sigma, it will become 2 cancels out, so it will sigma max. So so CA it becomes equals to sigma max, sigma CA becomes, this is not sigma max, so sigma max is this is sigma max. Basically this is sigma max, and this is also sigma max. So over here what happens? Sigma max becomes 0. Now this portion is also this portion sigma A is equals to sigma max. So this is becomes sigma max in the negative direction, and this is becomes sigma max in the positive direction. Sigma max and negative, and both are same. So that's why sigma A is like this. Now that is the most dangerous case. Now for this, up to here we have learned what type of fatigue loading. Now if you see the stress strain graph, what basically happens? Now if you see the stress strain graph, what basically happens. If you see the stress strain graph, what basically happens? You see that in case of a stress strain graph, so this is the stress strain curve. This is strain and this is stress. Now we are plotting for a engineering stress strain diagram. Now if you are plotting for engineering stress strain diagram, what you will get? You will get like this. You move, then for ductile material it will be like this. Now what happens for ductile material? It will like this. Now when you are loading, when you are applying the load, that is the maximum load. If the maximum load does not cross this, that is, if you are not going beyond the yield stress, what will happen? The stress will come like this, and when you release the stress, when we are going for a compressive force, what happen? In this case also, it will move like this. It will move like this, and what happened from here to here, it will comes like this. So this is a loop is formed. This is a loop is formed. A cyclic load is formed like this. A cyclic load is come like this. That is, in either case you are not crossing the yield point. In either case you are not crossing this yield point. That is in tension and also in compression. And also in compression, if you see, you are not crossing the yield point. Now this sort of loading is basically called high cycle fatigue. This sort of loading is basically called HCF, high cycle fatigue. That means more number of cycles are required. If you go on loading more number of cycles are required to cause fatigue failure, where the first crack appears. So it is called high cycle fatigue, or you could say high strain fatigue, because over here or low strain fatigue, because over here what happens? Here the strain developed is very less. Here the strain developed is not up to that point. So here the design is based on stress based design. For this sort of failure, design is based on stress based design, because stress is a controlling parameter over here. That is why high cycle fatigue is called high cycle fatigue or low strain fatigue. So high cycle fatigue that's why it is called as a stress based failure takes place. Over here the failure of the mechanical occurs, or the failure of mechanical is dominated by stress based design. So high cycle fatigue is basically stress based design, because because here the stress is a dominating criteria, because stress is a dominating criteria. So high cycle fatigue or low strain fatigue is basically called as the stress-based design factor. Now, what happens if we go for a load? If you see that if you are going for a cyclic load, this is the stress, this is the strain, this is the strain axis, and this is the strain axis. Now, if you are going for a now, if you see that if you are going like this, I have to take some more areas over here. Now if you rub this, you are getting some, basically now if this is a strain and this is a stress, now basically what happens, if this is a strain and this is a stress, basically what happens, you could see that this is a diagram. Now here for the ductile material, the material looks like this, and if you go for compression also, the diagram looks like this. Now basically what happens for this sort of failures, what happens? Basically the load is given. Now the applied stress is induced, crosses the applied stress induced. What happens? Crosses the yield stress for the material. That means the applied stress over here, see the applied stress generated over here crosses the yield stress of the material. Now before that we does not consider the material for high cycle fatigue, we does not consider material crossing the yield stress of the material, but over here we consider the material crosses the yield stress of the material. So the stress causes the yield stress of the material. So what happened? The material moves like this. Now at this condition, basically what happened? Here we stop loading. Now the material will come like this. Now we know unloading is always elastic. So the material comes like this and it moves like this. In the compressive force it moves like this. If you see the complete reversal load, it moves like this. So if you see the diagram, it comes like this. Now what happened? It moves like this. Now what happened? Now you became like this. You give a force like this. Now it crosses the yield stress. Now it comes like this. Again you give a tension, because it is a repeating cycle. Tension, compression, tension, compression. Now it moves again. Again it moves, and again it catches this point. So here also a loop is formed. Here also what happens? A loop is formed. The material comes like this, again it moves, and here what happens? Basically a loop is formed. This is known as the hysteresis loop. Now what happens? As the unloading takes place, the material will not follow this road. If material will follow this road, it will come straightly. Now it will move like this. So what happened? Because we know if you extend this region, so what basically happens is that this portion which is recovered is called elastic strain, eta elastic, and this portion which is not regained, it is called eta plastic. So here a plastic deformation is formed. For this reason, the material will not move from here. The material will take another path, and it will move like this. So over here this loop will take place. So this is called LCF. This is called LCF, or low cycle fatigue or high strain fatigue. This is called LCF, or low cycle fatigue, or it could be called as a high strain fatigue. Now this is the most dangerous condition, because the material is causing the yield stress as well as it is performing a repeated cyclic load. So this is normally takes place in nuclear reactor, when through the pipes, when you pass hot water and in the next moment you pass a cold water through it. So the pipe expands due to thermal expansion. It expands beyond the stress, and when it contracts, it comes down below and it contracts from its normal position. So it is a tension compression. So this is called a low cycle fatigue, or it is called a high strain fatigue. Now this condition, if you see these conditions are very dangerous. Why these conditions? Now basically what happens, this low cycle fatigue or high strain fatigue is designed on the basis of strain, strain based design. Why basis of strain based design? Because if you see that, if you observe that from this point to this point, the variation of stress is very less, but from this point to this point, the variation of strain is very much. So this sort of this loading is basically LCF, is basically based on strain, is basically called strain based design, Why strain based design? Because here the important parameter which holds the control is the strain, not the stress. Because here from here to here the stress variation is less, but over here the strain variation is much more. That is, it is called as a strain based design. And as we have discussed in our previous article, that way when we see a high cycle fatigue, if we see a high cycle fatigue, as we have discussed previously also, when we discuss a high cycle fatigue, it comes like this and it goes like this, and it comes like this and it goes like this. So a hysteresis loop is formed. Now over here, strain is not an important parameter. Strain is not an important parameter for the design. Here stress is important parameter for design. So normally it is called as this is called as the high cycle fatigue. I have discussed just previously. So it is based on stress based design. And low cycle fatigue is based on strain based design. So this is up to all we have discussed of fatigue failure. Now if you like my way of delivering the lecture, so put a thumb up to it, and keep subscribed to my channel for more and more uploading videos relating mechanical and automobile related topics. Thank you. Have a nice day.